Hey guys, welcome to my YouTube channel. I hope you all are good. Today's topic is real, rational and irrational numbers. Now let's see, what are real numbers? Guys, a set of real numbers is the combination of rational and irrational numbers, right? Mathematically, we can write it as R is equal to Q union Q dash, where R represents real numbers, Q represents rational numbers. This sign represents the union, means the combination, and Q dash represents irrational numbers, right? Now, the next thing is, what are rational numbers? Guys, any number which can be represented as A or B, where A and B belongs to Z, where Z represents the integers, okay? Where AB belongs to Z and B is not equal to 0, okay? This is the definition of rational numbers. Now guys, as you know, here we read it as A, B belongs to integers, okay? It means any number which can be written in the form of A over B in the form of ratio, you can say the number is known as a rational number. It means all the integers are also rational numbers, right? Yes, all the integers are also rational numbers. For example, 2. As you know guys, 2 is a rational number, 2 is an integer. So how it's a rational number? Because 2 can be written in the form of ratio. How? In this way. We can write 2 as 2 over 1, right? We can write 2 as minus 4 over minus 2, because this ratio of two integers is also equal to 2, which is an integer, right? In this way, as you know, integers are all the positive numbers, all the negative numbers. Now here the negative number, this is an integer, right? Minus 6. Minus 6 can be represented as a ratio of two integers. How? Same like this. Minus 6 is equal to minus 6 over 1, which is the ratio of two integers. Similarly, 12 over minus 2. This is also equal to minus 6. It means this is an integer, this is an integer. Similarly, all the other integers are also represented, can be represented as a ratio of two integers, right? Now guys, this is clear that all the integers are rational numbers. But the twist comes now. The thing is, as it's clear that all the integers are rational numbers, but the thing is, all the rational numbers aren't the integers. They might be integers, they might not, okay? But how? The example is here. These are the examples of terminating decimals. Terminating decimals are what? Let's see. Guys, here we have a decimal number 52.77. The decimal part is terminating, okay? There isn't any other number after 77, right? It means the number which is in the decimal part of this decimal number is finite, right? So this number can be represented as the ratio of two integers. How? You know, 52.77 is equal to 5277 over 100. And these all two numbers are the integers. So it means this is the ratio of two integers, and the ratio of two integers is known as rational number. It means this decimal number is a rational number, but this decimal number isn't an integer. It means all the rational numbers are in the integers, okay? This is another example. Guys, you know 1.4. The decimal part is finite, as there isn't any number after 4, okay? That is why it's a finite decimal number, right? This is known as terminating decimals, okay? Now this decimal number can be represented as a ratio of two integers, and the two numbers, you can say these are 14 over 10. As 14 over 10, 14 is an integer, 10 is an integer. It means the ratio of two integers, and this number is equal to 1.4. So as it's a rational number, so this number is equal to this number, so it's also a rational number, right? In this way, we can represent a rational number in the decimal numbers, okay? Now, another thing, if the decimal number, if the decimal part in the decimal number is repeating, for example, 0.33333 up to so on. If the number is same and it's repeated again and again, one thing, if the number is in the decimal part is repeating again and again, okay, we can write it as 3 bar, 0.3 bar. This bar represents that 3 is repeating, okay. So if the number is in this form, this number, this decimal number is known as recurring decimals, okay, recurring decimals. And guys, recurring decimals are also known as rational numbers. Why? Because the recurring decimals can be represented as the ratio of two integers, can be represented as a or B, where A and B belongs to integers. How? Guys, see, 0.3333 up to so on, this is equal to 1 over 3, where 1 and 3 both are the integers. So guys, these all are the examples of rational numbers, right? Is it clear? What are rational numbers? I hope so. Okay guys, now what are irrational numbers? Let's see. The numbers which cannot be represented as a ratio of integers are known as irrational numbers. Means the numbers which cannot be represented as A over B, where A and B belongs to integers and B is not equal to 0. These are the irrational numbers. These numbers have decimal expansion that neither terminate nor periodic. Neither terminate means there isn't any end of these numbers, okay? There isn't any end in these numbers. And they are not periodic means the numbers in such numbers will not repeat, okay? There isn't any number which will repeat itself again and again, okay? Now for example, this number 4.8257643 up to so on. This number is an infinite number. The decimal part in this number is infinite, right? So this is the example of irrational number. Another number, for example, under root 7. Under root 7, as you know, this is equal to 2.645 and up to so on. The numbers aren't repeat themselves, okay? They aren't a repeat, and the number is not a finite one. So this is another example of irrational number, right? Guys, these numbers cannot be written in the form of ratio, okay? So this is an irrational number. Is it clear? Okay, bye.